Hi everyone. Today we're going to do the line balancing problem, and these are the questions given. And we have the task table in which we have the list A to I, the task, and then we have immediate follower. That means that after task A, we have task C, B to D, and so on. And then we have task time. Check whether this is in minute or seconds, very important. And then they give us information on the output, the daily output, in which one day they produce 275 units, and they give us information also on the working time for the day is 440 minutes. So 440 minutes they produce 275 units. And then from here we need to calculate the cycle time, in which time to produce one unit. So from the cycle time formula, we gonna get 1.6 minutes in which time to produce one unit. And then we need to know the N. N is the number of workstation. These are the formula in which the sum time for all tasks, in which all the tasks from A to I, we sum all this, and then we divide by the cycle time earlier, 1.6, and we have 2.6. For workstation, you need to round up. So for this case, going to be 3. And we start to calculate the efficiency, and these are the formula for efficiency, sum of all tasks, and then we divide by n. You need to use the round number here, in which 3, and divide by the CT, and then we have 87.5%. And now we're going to rearrange all the tasks into the workstation. And then we need to draw first, okay, what we call precedence diagram. And from this table, again, we need to convert into tasks in which it is represented by the bubbles, and then the link, we're going to call it arrow. So from this case, it means that task A going to C and so on. And we have all the tasks, and then we have all the link, okay, based on the arrow here. Don't forget to put the numbers, the task time at the bottom. And then we have to apply some rules. For these rules, we decided to use the greatest positional weight or the longest processing time, which for my class I use it kepala, in which you have to find the biggest kepala here. So how to do it using this rule? You have to calculate the sum of time that involved for this process. For A task, we need to calculate from I at the end. So from the end, we're going upward. Okay? Oh, sorry, we're going backward. So 0 plus 0.3, we got 0.3, and then 0.3 plus 0.5, we got 0.8, 0.8 plus 0.1, and so on. Until the end, we have 0.5 plus 0.3, we got 1.8. That is the total processing time for task A. And then we need to know for task B. We do the same thing again, but be careful. Here, we need to go to F. 0.8 plus 0.6, we got 1.4, 1.4 plus 1.2, and so on until we get 3.2. Okay. Now we use the rule say that we need to choose the greatest positional weight. So for this case, I see that B with 3.2 have the greatest positional weight, and we will be starting at B. Okay. And now you have decided to start at B. So first of all, you need to have this table to assign all the tasks. So we have the first workstation, and time remain means we start with the cycle time every time we have the new workstation. So for this case, we calculated earlier is 1.6, and the eligible just now is either A or B. And since we put the rules of the greatest positional weight and we calculated, and we found out that B is the answer, so we have to use B. And the task time for B is 0.6. Okay, next, we're done with the B, so we just no more rules, and then we either have A or D. So for the remaining time is 1.6, we have used 0.6, so we have 1 minute left. So eligible just now is A and D. And then we look at the time. I think only fit A because D is 1.2. So only A can fit inside workstation 1 with the remaining time 1. And A is 0.3. And then next choice we have C and D. And then we go back to our table. And our remaining time is 0.7. Okay, C and D. And again, D cannot fit. So we will choose C. C is 0.4. And then next choice is D and E. And then go back to the table. We have balance of 3. And for this case, only 3 can fit D and E, but E, the only one can fit. So we have 0.2. And then next one, we can move to B and D, but again, only with the 0.1 left, the only one that can fit here is D. So, okay, we use everything up. So it's a very good assignment. We have assigned all the tasks to the workstation, so we can close the workstation without no idle time. So you have to draw the workstation so that you won't get confused, and then we will know that we're going to open the second workstation and our choice is E only. Why we cannot use H? Because F is not done yet, so you cannot skip F because F is fit into H. So H is no, so you have no choice, you will go by sequence in which D first, F, H, and then I. Okay, we go to workstation 2, open a new workstation, and remember we have to use the new city in which again 1.6, and we have only D choice. So we assign B, we have 1.2, and again we have done. So we're going to move to F, workstation 2. Let's see, the remaining time is 0.4, but wait, I think F is more than 0.4, so F cannot fit, so we have no choice, we have to close the workstation, and there's idle time 0.4. And then you have to do the same, to open the new workstation, and then we're done, and don't forget to put the line here, so that you know if you're done, and assign it to the second workstation. Now we go to third workstation. So we have F on the choice here. H cannot be done yet. So third workstation, again, new cycle time, and you only have F. F is 0.6. So F is done, and then move to H. And with the balance of 1, now you put H in, you have 0.5. And then you have balance. And then you have 0.3. 0.3. Then we have balance of 0.2. And no more tasks to be assigned. And you're done. So the sum of the idle time is 0.6. So again, this is the first workstation in which you assign A, B, C, E, and D. And then for workstation 2, you have D alone there. And then finally, the last workstation which I calculated earlier, workstation 3 or for F, H, and I. So check again, you calculate with the 3 workstations, so it's correct. So all the tasks have been assigned into the proper workstation. And don't forget to write in the total idle time is 0.6 minutes. Okay, I think that's all for the assignment, for the line balancing assignment. So if you have any question, you can just email me, or we can talk and discuss about it. Thank you.